It's a single register burner set up with a natural gas ring and a solid fuel center nozzle. The burner can be set for either clockwise or counterclockwise rotation, and the solid fuel nozzles are replaceable. It has a FireEye flame scanner and a spark to ignite the natural gas. There's a secondary flame scanner in the side of the furnace for backup monitoring. The natural gas is metered and controlled manually. The airflow is controlled manually but is not metered.
Tell me what I'm looking at.
It's a wood fire, about 3/4 of a million BTUs an hour, running with ambient temperature primary and secondary air. This burner is rated at 3 million BTUs an hour, so we're well down on its turn down curve.
Alright, now we'll go inside. Run in looking at the... Alright, tell me what you're doing, Fred.
Trying to zero the sulfur dioxide meter.
Okay, and what meter is that? Now, please.
Oxygen.
Alright.
It's coming down rapidly because he just reestablished the wood fire. Carbon monoxide,
What is that reading right now?
73 parts per million.
That's good or bad?
That's very good.
Alright. I'm looking at the oxygen content coming down, right?
Right. The wood will
Background,
burn.
you can hear the wood screw going in. Okay, what else should I be looking at here?
The wood will normally be burning at 3 to 4% oxygen.
Alright, anything else?
We've got the backup oxygen and carbon monoxide below it. There's a cross check on the other instrument. They're reading essentially the same numbers.
Okay. What is that?
That's the oxygen. Reading 6.5 compared to 5.5. This one's a lot slower.
Outside, taking a look at the stack gases coming off of the bark fire. You can see absolutely nothing coming out of that stack. You can hear the exhaust gases in the background. What's the outlet temperature, Fred?
About 1,200 degrees.
When I zoom in and look right at the flame, I can see some sparklers because now I zoom all the way down and look right at the end of the burner. That's what I'm going to do right now. We can see the sparklers coming right off the end of the flame itself. But we know they don't make them out of the furnace. So when I zoom back now, you'll find that those sparklers absolutely disappear because now we're looking at the back end of the furnace instead of straight in at the flame itself.
There'll always be some sparklers associated with firing.
Of course. I'll take this at various locations, various depths. Now we're looking at the flame a little closer, so maybe we can spot some design changes we might want in the burner itself. Now, at the throat of the flame itself, we're looking right at the throat of the flame, right where the swirl takes place. They call it.
You got it.
All right. Notice a pretty round and concentric swirl. We have now begun running on coal. We've concluded the wood test, and now we're running coal that is 80% minus 200 mesh. Go ahead, Fred.
Go ahead. Tell me what you see.
The coal is running at the minimum stable fire we can get in the furnace because of temperature limitations. SO2 with this coal is running about 1,600 parts per million, and we're at about 6% oxygen.
About 1,400 degrees Fahrenheit.
Is that a good looking flame?
Yeah, that's a good flame. Looks a little hazy because of the ash content.
Can you tell me something about the coal we're burning?
The high sulfur Illinois #6.
Illinois #6 coal with what do you think the sulfur content is?
3.5, approximately.
3.5. All right, we're going to go a little closer towards the flame now.
furnace temperature is 1525.
Walk over there. Tell me what's going on. Aha. You're not kidding, are you?
No, that sulfur is strong, fella.
Okay. This is the output from the furnace. Tell me, what do you see, if anything? You don't have to stand there, just tell me what you're looking at.
Looking at fly ash
You see the ash coming off?
and a lot of sulfur.
Okay, what percent sulfur?
3.5% full. 1600 ppm would be about a 0.15% in the gas.
Okay, would you say the combustion looks fairly decent?
Yes, combustion is excellent. The ash is a light grayish tan color, indicating complete carbon burnout. There's no pulsations at all with the fly ash or exhaust. So the fire is very stable.
What we've got here then. Go ahead.
Okay, the top line is carbon monoxide. It's beginning to creep up now because I just put it on calibrate. It's been running essentially 0.
Alright.
The middle line is oxygen. It's running between 9 and 10%. The dip was caused by a range change for calibrate. Bottom line is sulfur dioxide, running between 15 and 1600 parts per million.
And is that normal?
Those are normal readings for this coal, yes.
And we hope that by the introduction of limestone, we get that to drop.
Yes, we'd like to get a 90% reduction in sulfur dioxide.
Okay, I'm being told that we are down to 450, and at the present time we are feeding how many pounds an hour?
I'll have to look at the chart.
We're feeding 81 pounds an hour of limestone, and how much coal? 150 pounds an hour of coal. We have reduced the sulfur content by 2/3. Okay, tell me what you're doing, Mark. You're mumbling.
Checking the calibration on you.
Okay. All right, Fred, what do you find that the calibration went down to? What did it finally get down to?
We got readings as low as 130 parts per million. Sulfur dioxide.
At what feed rate on the limestone? Versus 150. 90 pounds an hour versus 150 on the coal.
Correct.
All right, Mark, can we take a look at that?
All right, Mark, what am I looking at now? This is the calibration section.
Clean check valve.
Yeah, let me,
You need the 9/16 screwdriver.
the test data where it's been going down steadily.
All right, you point out which part is which.
This is SO2. You see it, it's coming down.
Stand by.
It's 1047,
Stand
1022, 468, 190, 130. It's continuously going down.
So as we up the increase of the limestone,
It just
the SO2 dropped.
progressively.
All right, thank you.